And to speak to the entire audience, click Start Broadcast. Hello, everyone. Welcome to our webinar today, Routing Electric Transmission Lines from Commonwealth Associates. As people start flowing in to the presentation, we'll just wait a short moment to make sure everyone's all settled. We're really excited to have you here today. And from what I know, working with Doug, we're really looking forward to this presentation.
Yes.
All right. All right. So in the for the sake of time and respecting your lunch hour, we appreciate you being here. Let's get started. So in today's environment, routing a new electrical transmission line can be a challenge. In this webinar, we're going to discuss the routing process and provide a path for others planning to take on this daunting task. In this webinar, we're going to be covering the transmission line routing process, the natural and built environmental considerations, right-of-way and engineering challenges, and a simple routing study. Here with my Commonwealth expert routing professional, Doug Longpre. So we'll get to that in just a moment. But before we do, some quick housekeeping tips or bits of info. Next slide, please. All right, so here we are today, routing electric transmission lines. Again, thank you all for coming. Something that you may be aware of in some of the marketing material is that this presentation can be used as a PDH, like Learning Professional Credit Hour. You will be receiving a certificate of completion after the webinar, about an hour or so after the webinar is complete, and that will have a certificate in it. So that certificate, along with your email that it came with, should be good enough to submit to qualify for your PDH. We haven't had any trouble with that in the past, and it seems to work out really well for everyone. We will also have a Q&A session at the end, so if you have questions for Doug, there is a question box in the control panel of GoToWebinar here, so feel free to put your questions in there or in the chat. And after the presentation is over, Doug and I will be doing a little Q&A. I'll be asking him your questions, and he'll answer them to the best of his ability. The next slide, we're going to do some webinar tips because we want to make sure that this is not just informational, but also enjoyable, and that you get the most out of it as you can. So if you see your GoToWebinar control panel, you can select your audio preferences if you need to change the speaker or your headphone setup to hear the audio. The questions little section there is where you can ask a question. We don't have any handouts today, so you don't need to worry about the download handout, but then there's also a group chat where you can chat with folks, with myself, you can ask questions, or other people within the presentation space here. So hopefully this will help create a much more enjoyable or an even more enjoyable webinar experience for everyone here. Lastly, next slide. I would like to announce our next upcoming webinar. It's August 21st, 2024. The topic is going to be CHP RICE, layout considerations for combined heat and power facilities. So that is all of the housekeeping I have today. Thank you for bearing with me on that. And without further notice, we're going to get to our presenter. So Doug, take it away.
Thanks, Dal. Appreciate it. So my name is Doug Longpre. So yesterday, my webcam wasn't working, so I thought I would show up with a t-shirt and be good to go. But it looks like my webcam is working, so now you can put a face to the name. So I'm a senior environmental specialist at Commonwealth Associates. I've been working in the environmental field for 27 years. My experience includes 2 years at the Michigan State University Systems Modeling Lab doing GIS work for graduate students, 9 years at a small surveying engineering company delineating wetlands, developing wetland mitigation plans, conducting tree inventories and habitat assessments, and state and local permitting. I have been at Commonwealth for 16 years. My work entails transmission line routing, erosion and sedimentation control planning, access planning, and permitting at the state, federal, local level, also drone work. I've been a drone pilot since 2018. So this is an overview of what we're going to be talking about today. And you can see from here down to here, I got a lot of stuff, and then routing the new line is way at the bottom. So this part right here takes up 19 of my 68 slides. So there's a good chunk that is routing on the new line. I just don't want to break it down into more and more bullet points. So just hang on. So what is not covered in this webinar? Substation siting, the public meeting aspect, and development of the routing report. So all of these three things can probably make up another webinar, and I just don't have the time to put that information into this. So the method I will be discussing is referred to as the links and nodes methodology. It's a methodology that we've been working with for a while and has worked well for us. It relies on GIS data collection, digitization, ranking, and expert judgment. You can apply weighting if you need. Sorry. So EPRI, Electric Power Research Institute in Georgia Transmission, created a methodology back in 2007. It relies on GIS modeling and analysis to determine the study area boundaries, uses least cost path method algorithms to determine macro routing corridors and alternative routes. The preferred route is selected through expert judgment and ranking the alternatives. So we've got that expert judgment in there. I've also heard of the analytical minimum impedance surface method, but I don't know a whole lot about that. So what is meant by routing? It is the process of identifying the optimal path from point A to point B while balancing impacts on the human and natural environments and taking into consideration costs to purchase right-of-way and design and construction of the line. So essentially, we're trying to identify a path that avoids wetlands, steep slopes, crosses few streams and rivers, low pole heights that don't interfere with airport flight surfaces, impacts little floodway and floodplain, while at the same time avoiding all of this stuff down here. Yet it is cost efficient to build. Does it sound daunting? It can be, depending on how you route. So what is the goal of routing? The goal is to gain a detailed understanding of their opportunities and constraints within a defined area, facilitate the development of preliminary and alternative routes, evaluate potential impacts associated with the alternative routes, and ultimately to identify a preferred route for the new line. And you will see these terms, what these terms mean as we go through the webinar. Before we get into routing, let's discuss the need for a new transmission line. Most of us would assume that a utility or transmission company would not spend money on routing a new transmission line if it did not have a clearly identifiable need for the new line. However, some transmission line projects can be stopped in the permitting process or in courts because the transmission developer did not properly prepare a need statement to explain why the new transmission line is needed. So you need a need statement. It doesn't have to be fancy if the project is not expected to be controversial. It should be in depth if the project is expected to be controversial. And it should come from the client and their attorneys. It should tell you why the line is needed. Maybe you're going to interconnect a new generation facility. You need to support growth of system load. You need a new substation. So information to consider: historic and projected loads, present and forecasted generation resources to meet projected loads, transmission system limitations and bottlenecks, results of typical planning studies and modeling, NERC and ISO planning requirements for reliable system operation, economic criteria to provide for prudent and least cost planning. The transmission developer must provide factual information in the form of written text and tabular information that describes the planning basis and criteria used to determine the need for the proposed transmission line. It's very important if the project is anticipated to be controversial. So all possible alternatives need to support the need for the new line must be discussed in the needs statement. However, the conclusion must be reached, and I can't say this enough, the conclusion must be reached that the recommended new transmission line best meets the need. If this conclusion is not supported by the facts, then one of the other alternatives should be implemented instead of building the new transmission line. So what alternatives do we look at? We've got the do nothing alternative. That's the consequence of not constructing the proposed transmission line or implementing any other alternative. The typical do nothing alternative results in either the transmission system not meeting the planning and reliability criteria or the loss of an economic benefit. We also have system alternatives. There will always be system alternatives to building the new transmission line that must be evaluated. The basic question to answer is, would implementation of any of these systems alternatives make the proposed transmission line unnecessary? So we're talking about instituting demand management procedures, implementing system operating procedures to obtain the desired results, installing special protection systems, or adding system controlling equipment. We also need to make sure that we look at transmission alternatives, like upgrading the existing line by reconductoring, adding a circuit to an existing line, rebuilding an existing line to a higher voltage. And then there is the going underground alternative. That discussion of underground transmission options is always a requirement. So we have determined there's a need for the new line, so let's start preparing to route it. And I say preparing because there's a lot to do before we start routing. First, we need to select a routing team. For all lines, a good faith effort of routing requires that we get input from a variety of viewpoints and sources. In less complex areas or in areas that are not expected to be controversial, the size of the team can be relatively small. However, the basic team should have senior representatives from the fields of transmission line design, right-of-way acquisition, and environmental. For controversial projects or projects that may require public interaction, other team members should be added to deal with the specific issues or to respond to natural resource and human values that may exist in the project area. So we might want specialists from agricultural visual impact assessments, forest and wetlands, wildlife habitat management, GIS, and even local stakeholders, people that live nearby. Next, we need to establish the project. We need to establish a name and use the name uniformly by all project participants. Check the RFP, the request for proposal, and the purchase order. If you can't find what you need, ask the project lead engineer or ask the client. You need to establish a direction of flow. The team and public, if necessary, need to have a mental image of how the power is going to flow. All maps, data, surveys, drawings need to follow this flow. So generally, it can be north or south, south to north, but should be west to east because that's how we read from left to right. You need to collect basic design information. This will need to be included in the routing report. So we need to know the physical characteristics of the transmission line to be routed. Where are the endpoints? What are the substation names? Are there any intermediate subs? Are we going from A to B to C? What is the voltage of the line? What is the right-of-way width? How tall are the poles and what are they made of? Wood or steel, single pole or H-frame? How many circuits are there? Are we going to direct embed or custom or a mixture? What are the span lengths and is there any underground? So how is the line going to be constructed? We need to know what the equipment is going to be used. What is the construction sequence and where are materials going to be delivered? This all needs to be in the report. We need to set some guidelines next. So there are general guidelines and technical guidelines. General guidelines help establish a set of principles that guide the development of alignments with respect to area land use, sensitive features, and considerations of economic reasonableness. I know that's a weird word, but I had to look it up and it's actually a word. Need to ask yourself, what are you going to avoid or minimize impacting? So for general guidelines, that may include avoid excessive length and circuitousness. That's a word also. I had to look that up. Avoid overlapping or co-locating with railroads and pipelines. You may want to do that. Avoid or minimize crossing through residential neighborhoods and large commercial developments. You may have to do that. Minimize using existing distribution easements. You may want to do that as well. Maximize the separation distance from and minimize impacts to airports, residential dwellings, commercial buildings, schools, daycares, facilities, hospitals, churches, and other community facilities. You want to avoid crossing directly over road intersections. Avoid crossing or minimize impacts to designated public resource lands, such as parks, large recreation areas, sanctuaries, preserves, designated historic resources and sites, and conservation areas. You also want to avoid or minimize crossing large lakes, rivers, wetlands, complexes, critical habitat, and other unique or distinct natural resources. So those are our general guidelines. So technical guidelines provide the routing team with technical limitations related to the physical environment, project design, right-of-way requirements, and infrastructure reliability. They include minimizing the number of angles along the transmission line route. That's going to reduce the number of custom structures you want. Minimize the number of crossings of transmission lines of equal or higher voltage. It's going to require special structures if you do that. Consider long-term operation and maintenance of the transmission line. Maybe minimize angles greater than 65 degrees. You can set that to whatever you want. Cross roadways, rivers, and railroads at a close to perpendicular angle where reasonable and feasible. Avoid placing structures within limited access right-of-way, such as freeways. Avoid placing structures in an area that may cause the structure to extend into an airport imaginary flight surface. And you'll hear more about that later. So you need to define your constraints as well. Routing constraints are defined as specific areas that should be avoided to the extent feasible during the route selection process. They are generally divided into two groups based on the size of the geographic area encompassed by the constraint. So we've got large area constraints and small area constraints. So for your large area constraints, think big. We're talking public use airports and airport facilities, golf courses and other large public and private recreational facilities, sites listed or eligible for listing in the National Register of Historic Places, historic districts, local and state parks, as well as public recreation areas, nature preserves, sanctuaries, and conservation areas. And then we also have sand and gravel mining areas and wetland complexes. So for your small area constraints, think small. We've got individual residences, commercial and industrial buildings, gas and oil infrastructure such as pumping stations, control stations, and other pertinent facilities. And then we also have our places of worship and cemeteries, so our churches and cemeteries, schools and hospitals, designated historic buildings and sites, recorded sites of designated threatened, endangered, and rare species or unique natural areas, developed public recreation areas, facilities and trails, communication and water towers, and pivot irrigation systems. So constraints may be different for each study. For example, wetlands might be a constraint area for a routing study performed in an area of dense urban development or in intensively cultivated land where there are very few wetlands. However, in an area where there are extensive wetlands that cannot be avoided, designation of wetlands as a constraint would not be productive. So you need to define your opportunities as well. Routing opportunities are areas where a transmission line might be located with minimal impact. They are typically identified and evaluated by a review of aerial photography and other available mapping data, incorporation and consideration of available geographic information system data, field investigation of the study area, input from others familiar with the project area, and routing team experience with similar projects. So let's start routing new line. So we'll be getting into a routing study we performed last year. It's a single circuit 69 kV line with a variable width right-of-way, 60 feet along roadways and 100 feet within agricultural fields. And it's in a relatively high density area. The client indicated they wanted to avoid the project being controversial to the extent feasible. For lines that are 345 kV and up, you would see straighter lines within wider right-of-way corridors. The impacts to the human and natural environment may be harder to avoid because of the wider corridor and straighter lines. So when you develop your routes, what we do is we develop them in Google Earth with the assistance from GIS. Our measurements and counts are placed in an Excel spreadsheet, and you'll see that later. Generally, data is collected for what the route center line crosses, what the right-of-way crosses, out to as far as 500,000 to 2,000 feet. Report maps are developed in GIS, and if needed, Google Earth information can be placed in a GIS database for analysis. So the first thing we want to do when we're routing is identify our endpoints. So system planning considerations typically dictate the transmission line endpoints. That should come from the client. Once the endpoints are identified and provided to the routing team can then proceed to develop a study area. So we have our endpoints and direction of flow. So we have point A, we've got point B, and we're going from A to B. A is a proposed substation, B is an existing substation. So what do you see as a potential study area at first glance? So my first thoughts were, I see this here and this here. Looks like a good shot right through here. That was my initial study area. However, You need to define the project study area. The study area is that territory in which routes can be placed to meet the functional requirements of the project while minimizing human and environmental impacts and project costs. The initial boundary of the project study area is determined by the geographic area encompassing the endpoints. The boundary of the study area is then sized to encompass all reasonable routes between these points. So we expand it later on. May end up changing once the team has had a good look at the constraints and opportunities in the study area. So we determined this to be the study area. You can see that we extended to the south and we extended it to the north. We saw a nice straight shot up here. We saw a nice straight shot down here where we might be able to avoid putting poles along the state route. So start collecting information and building your database. Don't be afraid of collecting information outside the study area. Information is obtained from many sources, including federal, state, and local governments through their official agency GIS data access websites, and some is created by the routing team through digitization and aerial photo interpretation. And I can say that a lot of it is done through digitization. Many of the sites do not have files you can download and bring into a database. This will require looking at their maps and determining where the asset is located in GIS and in Google Earth, and then digitizing. So what do we collect? We collect parcel information, agricultural district information. So make sure you do not include ownership information. You don't want to give the appearance of showing favoritism. Habitable structures, very general, may need to digitize. Same with land use, land cover. Historic architecture, we're looking at historic places as well as historic districts. We're looking at institutions such as schools, places of worship, and cemeteries. A good source is Google Maps. Find your nearest airports. SkyVector is a good source for both public and private facilities. Here's an example of the map. Pretty complicated, but if you look, you can see the restricted areas in there, and it will identify where your public airports are. So what we typically do is measure out 20,000 feet from the nearest runway to determine if any routes will be impacted. And you'll see this later. We insert anticipated pole heights for impacted routes into the FAA Notice Criteria tool to determine potential height restrictions. And we go from there. So not all private airfields are on SkyVector. So you need to make sure to search your study area very well and look for runway markers, marker balls. And the other thing is long, very long strips of grass that are very narrow. We also look at threatened, endangered, or rare sensitive species. Make sure to submit for a T&E species review for the study area, either from the state or from IPAC or both. IPAC is from the Fish and Wildlife Service, and it's the information for planning and consulting. So we want to look at soils and farmland. We're looking at prime farmland and farmland of statewide importance. This could affect how you cross your farm fields to get to your right-of-way. The farmers really want that soil, so they may want you to windrow it off to the sides. The problem is now you've got a big bath. So you need to make sure to deal with that. So roads, we'll need to identify how many different types are crossed and paralleled. Underground pipelines. There's a national pipeline mapping system that really is very nice because it tells you if there is something in the area. However, you can't zoom in very far and lines are not very accurate. Usually requires dropping down to Street View in Google Earth to find roadside markers. So if there's no Street View, look while in the field. You can also back up years in Google Earth to see dry areas in the fields or areas of construction. We also have environmental action sites, such as contaminated areas and brownfield sites. So for our study area, information we've collected is starting to take shape. We've got some tile drains down here.
Hey,
We've got some,
Doug, quick, I did get a comment from the audience that they can't see your mouse, which I understand, or your pointer. And so if when you're asking where, telling where things are, you could just maybe provide a bit more verbal reference. I think that would be super helpful.
Okay.
So my fault.
Sorry.
Thank you.
Sorry.
Oh, you're good. Thank you, though.
So you can see there are, so our study area information is starting to take shape. So we have light blue lines down at the bottom, which are tile drains. We've got dark blue lines, which are our streams. And then we've got ponds, which are also light blue polygons. So now we have schools and existing transmission and distribution lines. So if you look on the far east side, we've got a big high school. And then on the north side, we've got another high school. And then the brown lines are existing transmission lines, and the purple lines are existing distribution. And all of this has been digitized. So what you might end up with is something that looks like this. You've got a lot of parcels. You've got floodplains up in the northwest. You've got cemeteries, and we've got gas and oil. I wish I could show my mouse. This is very difficult. So on the west side is gas and oil, floodplains, and then we've got cemeteries, we've got schools, we've got towers, we've got parks and recreation areas, we've got trails, we've got all of our parcels. We know where fire and EMS are, and you can see there are two red lines, one arcing over the center of the project and one arcing down to the south of the project. Those are our 20,000 foot measurements for our airports. So now we want to identify conceptual routing corridors. Conceptual routing corridors are very general and provide the routing team with direction for determining preliminary routes. You can skip this if you want. For me, it's a process thing, and I think it helps the client to see how we are building our routes. It's very general. So we have point A and point B here. We have our route here. We've got a route in here, and we've got a route in here. We're going to look at everything in between here and even down in here, or down to the south, I should say. So we're looking at everything in between these routes. Sorry, since you can't see my mouse. So now we need to define the preliminary route network. The conceptual corridors and the areas surrounding the corridors are then divided into multiple interconnected route segments by adhering to the previously defined general and technical routing guidelines, the general and technical that we discussed before. Efforts are made to develop segments throughout the entire project study area to ensure all reasonable alignments are considered. As information continues to be collected and reviewed, route segments are refined. Where two or more segments intersect, a node is created. And between the two nodes, a link is formed. Together, the interconnected links form a preliminary route network, and routes are identified by following links within the network to form preliminary routes. We actually number all of our links, which allows a common language when trying to describe possible routes. So this is our preliminary route network. You can see we've got a lot of segments in there, and each one of those segments in between nodes are numbered. So if we were to go from point A to point B, no matter which way we go, we have the ability to identify segments. And if somebody wants to go to a different direction, they could say, well, let's go from segment 10 to segment 12, rather than let's go down North Street or the area outside of the commercial building that I don't know the name of. So next we want to identify our preliminary routes. Preliminary routes are an early iteration of the routing process that involves following different links through the study area to get from point A to point B. Consideration is given to large and small area constraints and opportunity features within the study area. As the routing effort progresses, links are removed, added, or adjusted. These changes may be based on length, the likelihood of impacts to residential, commercial, or industrial areas, as well as impacts to surface water features or natural areas. May also end up expanding the study area. Be sure to eliminate links and nodes that are no longer being considered. So we followed our route network and we came up with 8 preliminary routes that we thought were feasible. We've got a pink route down here in the south. And since I can't show you with my mouse where I'm going, I'll just say there's a pink route. Under the pink route is a green route that goes up along the freeway. There's another green route in the middle. There's a yellow route that overlaps with a light blue route that goes to point B. Then the yellow route wraps up and drops down to point B. There's the purple route. There is a light orange route that overlaps with the purple route and drops down to point B. And then we have another route that's way outside and goes along the freeway. So you can see that we extended the route study area to include the area up in the northwest. So be sure to collect necessary data within the extended area and adjust the links and nodes network. And all the routes are identified in the report by link numbers from west to east. Once the preliminary route network has been developed and preliminary routes have been identified, qualitative and quantitative screening process is used to determine if any routes not considered suitable for further study could be eliminated. Potential impacts by each route are then assessed and comparisons are made between land use, natural and cultural resources, right-of-ways, and engineering and construction concerns. Be sure to eliminate links and nodes that are no longer being considered. Basically, we're trying to reduce the number of routes to something that is manageable. If you've got 8 to 12 routes and you're trying to do counts on all those routes, it's going to take days and days and days and days. So if you can drop it down for specific reasons, then that's a good thing. So we went from the initial 8 routes down to just 4 routes. So you need to justify in your report why you eliminated the routes. So we eliminated the south route, the pink route down at the bottom, due to limited pole placement between building, sidewalk, and curb. Here's a street shot view. You can see how close the houses are. You can see there is not much room between the sidewalk and the curb. Putting in a 69 kV pole in there probably would have disturbed the sidewalks and would have required a lot of infrastructure changes. We eliminated the middle route due to the inability to expand the right-of-way through a residential neighborhood, even though distribution was already present. So over by point B, there are several neighborhoods. This is what it looked like in the neighborhoods. You can see that we are close to houses and accessory structures. Right beneath the pole that you see in front is a building. and there's lots of trees that would need to be cut. There would have been lots of pushback from the owners. So we eliminated the road along the freeway due to the limited access and expected inability to maneuver equipment near the sound wall. Also would have needed to go through subdivisions. So at the north end, we could have had an access just to the east or west of point B, but that access would have gone through a residential neighborhood. Where 75 intersects with 571 down at the south, we would have had to go through a commercial area. That would have been fine, but trying to do a mile-long stretch next to a sound wall with all kinds of trees and in people's backyards, there would have been a lot of pushback. So you can see the black line next to the freeway. There's a green line and then the freeway, and there's a black line. That's the sound wall. So the green line is where we were proposing to put a transmission line. And we would have had to cut a lot of trees. So there would have been a lot of pushback from neighbors. So we eliminated the medium north route because the client didn't want to double circuit the existing line or create a tunnel effect by going to the opposite side of the road, which also passed by a church and a school. So you can see on the left side, there's an existing 69 kV transmission line. On the right side, it's open. And this is where we propose to put a transmission line. But when we discussed it with the client and told them that it's going to create a tunnel effect, they were very against that. And they also couldn't double circuit the existing 69 kV line. So I have a side note. So make sure you will need to show the routing report what you have collected. Remember from earlier, generally data is collected for route crossing. So your route crossing right from the center line, the right-of-way crossing out to as far as several thousand feet. So 50,000, probably 2,000 feet. You need to collect information for each of the alternative routes. So we're doing our counts and measurements. Keep in mind, you may need to justify your findings in court. This is typical beginning of a spreadsheet that we use. Many, many lines after. Break into natural environment, human environment, and then right away in constructability for the report. So we generally put together one Excel spreadsheet, and then we break it up into the 3 different factors. So back to routing the new line. So we have our alternative routes. So route selection study requires reviewing alternative routes in the field. Features are observed in the field are correlated to information shown on a laptop computer or on paper maps displaying aerial photography and GIS data. This allows verification of GIS data and aerial imagery collected during the initial stages of the routing process and assists in identifying new constraints and opportunities not initially identifiable during the desktop review. Routes may end up being modified based on the results of the field evaluation. So now we need to compare routes. Yes, I'm going into more bullet points. This is when alternative routes are discussed and where there are summaries of the quantitative and qualitative analysis and potential impacts to local communities, the environment, and cultural resources. The alternative routes are reviewed in detail and then compared and ranked using a combination of information collected in the field, GIS data, sources, supporting documents, and the collective knowledge and experience of the routing team. So think back on that, that spreadsheet that I showed you. So we are looking at natural environmental impacts such as prime farmland, may need to blade the topsoil into windrows. I think I mentioned that before. Hydric soils. If you have hydric soils present, you may have wetlands present. Timber matting for access may be needed. Custom structures may be needed, and it may involve extensive permitting. So vegetation, does tree clearing need to take place? Bat habitat and construction timing needs to be considered. Surface waters such as streams, rivers, and wetlands, if impacting, could require lots of permitting and possibly mitigation. Then you have your flood hazard and floodplains and floodways. So now let's look at built environmental impacts. So constructing a new transmission line can affect the built environment by directly and indirectly impacting residential structures and parcels, commercial and industrial developments, institutional uses, so schools, places of worship, cemeteries, and hospitals, and cultural resources and land use. So what we are looking at is land use and land cover, conservation and other easements, parcels and building crossed, recreation and aesthetics, such as parks and recreation areas and areas that are aesthetically pleasing. We also have cultural and other resources. Typically, we don't do archaeology because we don't have access to the database. We do have access to some cultural though. So we also want to look at schools, memorials, cemeteries. Memorials was one that we got nailed on a project quite a while ago that we didn't see, where somebody was killed during an accident and it was a designated memorial. So need to really make sure to go down the street view and check out what you have there. So cemeteries and churches, fire police, airports, environmental action sites. The term constructability is used to discuss the feasibility of constructing a transmission line as it relates to engineering, right-of-way, and construction concerns. Constructability evaluates the use of existing infrastructure corridors, engineering challenges that might be encountered, and potential construction accessibility issues of a proposed route. Major factors that can affect constructability include, but are not limited to, steep slopes, condensed right-of-ways, sharp angles, proximity to major highways, accessibility, and cost. Additional factors to consider when evaluating constructability includes ease of moving equipment, materials, and workers to the construction sites, the relative ease of ensuring public and worker safety, logistical difficulties associated with obtaining the required easements for the transmission line, and the actual amount of time and materials needed for construction, which can correlate with route length. So the longer lines may require more materials and often a larger construction period. So what do we look at? We look at line right-of-way. Right-of-way easement widths can vary based on voltage, number of circuits, and other engineering requirements of the transmission line. We want to look at existing distribution right-of-way. Underbuilding existing distribution can be cost effective during easement acquisition if the width of the transmission line right-of-way is the same as the width of the distribution right-of-way. If the right-of-way needs to be expanded to accommodate the transmission line, then new easements will need to be acquired. In addition, coordination with the distribution owner can be difficult and time-consuming, unless it's your same. Pipeline crossings. Crossing pipeline right-of-way can increase environmental and engineering costs by requiring in-depth permitting and special structures and cathodic protection measures. Other infrastructure. Crossing over or under other infrastructure can increase environmental and engineering costs by requiring in-depth permitting, special structures, and increased span lengths. So road crossings. Crossing interstates and other roadways require special planning and permitting through transportation departments. So we also have route deviations that we need to consider. Route deviations are counts of how many times the actual drawn line for route changes direction. They can provide a rough estimate of how many custom poles a route may require and what the angles might be. So we also have operation and maintenance to consider. How do we access the line in case of emergency, for maintenance, or for addition of another circuit? And then project costs. For engineering, take into consideration route length and costs for structures, foundations, hardware, conductors, and labor. For right-of-way, take into consideration route length, route area, number of parcels crossed, and labor services. Once a preferred route is selected, a more refined estimate as well as access plans can be provided. It is important to note that these estimates are likely to change throughout the process as the project moves from routing to design and through the permitting and construction phases. So a selection of the preferred route. The preferred route best minimizes the overall impacts of the project on the natural and human environment while avoiding unreasonable and circuitous routes, extreme costs, and non-standard design requirements. The rationale for selecting the preferred and alternate routes is derived from the accumulation of the routing decisions made throughout the process, the knowledge and experience of the routing team, and the comparative analysis of potential impacts. The underlying goal inherent to a routing study is to reach a reasonable balance between minimizing potential impacts on one resource versus increasing the potential impacts on another based on the data and professional judgment of the project team. So we were down to 4 alternative routes. We eliminated the north route, the orange one to the north, because it passed through a large wetland and park, but also because it was the longest route and would have required many angle structures along the freeway ramp. So you can see where the 75, where it says 75 to the north, there would have been a lot of angle structures going around that ramp. We also ran into FAA issues with proposed pole heights impacting the flight surface of an airport to the north. So the same area where you see that 75, if you go to the northwest and extend further west and then extend south, we put in poles into the notice criteria tool, and it started coming up with poles that needed to be 70 feet high. So we were looking at more like poles that were 110 feet high. So in this case, 2 preferred routes were selected. We've got the yellow route and the green route. And the yellow route, green route kind of overlap. Both are feasible. Both were depending on another route study being conducted by the city that they didn't want us to interfere with. So they had their own preliminary, but we didn't know what their preferred route would be. We based ours on what they might not choose. So we selected the yellow route to be a preferred. It was short and had very few negative impacts and was the least costly to construct. We also selected the green to be the other preferred. This was the next shortest and had very few negative impacts and was also the second least costly to construct. We also selected the purple route to be an alternate to the preferred routes in case the preferred routes were unable to be constructed. It does go through a wetland and a park, but was shorter and less costly to construct than the eliminated alternative route that went further north. We spoke with the client about the route to ensure they would be willing to deal with the pushback and possible wetland permitting, and they were fine with that. Of the 2 preferred routes we proposed, the client eventually selected the yellow route for the new line, right through the center. So that's the end of the routing study. However, Routing the new line is designed to provide the pathway for the next steps in the overall project, which is property research and right-of-way acquisition and permitting. So title commitments will identify interested property owners and other property constraints. Sometimes you end up with certain areas that are restricted or whatever that aren't out in the public knowledge. So you have to, you'll end up identifying these with the title commitments. Permit matrix will help to identify all possible permits that may be needed for the project. The routing report will provide valuable information to assist with reroutes if needed during the right-of-way acquisition project. Oh, that was long. So back to you, Del.
All right, thank you, Doug. I really appreciate your insight and your expertise in this topic. So we still have a few minutes left, and we're going to open up the Q&A. So if anyone has questions for Doug on this topic, feel free to put them in the question box or the chat and send them on their way. And we'll get to that here in just a moment. As we wait for the for some questions to come in, I did want to say that we do have our webinar in August coming up on RICE and CHP, and we look forward to having you back or having you share these opportunities for webinars with people that you may know. Also, everyone who registered and attended or registered and was not able to attend will be receiving a link to the recording to watch on demand whenever you want, wherever you want, and you are free to share that link with other folks within your organization who might find the this presentation, Doug's information, very useful. So let's get to some questions. So first question, Doug, I want to say is, hold on, I got to get this. I'm going to pop this out here real quick. Okay. So why did you not include the public process? We talked a lot about neighborhoods, public, but you didn't go into that. Can you tell us about that?
Yeah, that's just a very complicated process. And like I said at the beginning, it can require, or it could be another full webinar. I just didn't have the time to put in the information on that. It can be very complicated, and there's a lot of information as to how to handle the public and how to put together your presentations and all that stuff that I just couldn't get into.
Okay, understandable. An opportunity for a webinar in the future. That could be fun.
Yes, absolutely.
Here's another question. This one's from Micah Holtz. Asks, how is the routing process different when done on behalf of an independent power producer client looking to take an advantage of an open access transmission tariff, as opposed to doing the routing for utility?
Oh, I have no idea on that, Del.
That's all right. That's all right.
I can look into that though.
Okay, so Micah, thank you for your question. I'll make sure that Doug gets this question, and we'll follow up with you a little later. But thank you for asking.
Yeah, because I have no idea about tariffs and all that stuff. So
okay, so the next one is: do you have experience routing within equity criteria, e.g., avoiding low equity neighborhoods?
You know, that is something that we don't have experience with. There is no data out there that I'm aware of that has that information in there that we can look at. It may be something that we searched though. Didn't even think about that. Yeah. I mean, we look at areas that have, we found big areas of where assisted living facilities are and things like that. But yeah, for that, we haven't looked at that.
Okay, so another something.
Thank you.
Another something to consider. I appreciate that. This is really good, really helpful.
Yeah, if this person can point me to something, I would be very interested to know how to apply that to our routing study.
Yeah, for sure. Well, let's see. I'm going to make sure that we get those for questions to be answered at a later date by Doug or someone else who might have that information. Okay, well, that looks like it's it for the questions for now. Again, if questions come up later on, feel free to email me, the attendees. Feel free to send me an email. We'll make sure you get your questions to the right place and get a response to you. My email is within that the emails you've been getting from GoToWebinar. I look forward to hearing from you. So with that said, that does wrap up our time here today. Again, thank you to Doug for taking the time to share your expertise. Thank you to everyone who took some time out of their day to hang out with us and learn about routing electric transmission lines. And we look forward to hopefully seeing you again. Again, my name is Del Belcher, Marketing Manager at Commonwealth Associates. And on behalf of the Commonwealth, thank you for coming and have a great day.
Thank you, everybody.